So thank you all for coming. You have found yourself at the Using R and RStudio on Hyak Klone workshop. So I'm Kristen Finch. I'm the Director of Research Computing Solutions in UWIT and part of the support and management team of Hyak Klone. Today we're going to talk about R and RStudio, of course, but I am going to give you a little bit of background information about UWIT Research Computing Services, where you can find user support, and if you're a student, how you can get student access to our resources through the Research Computing Club. We'll go through why use Hyak for your R workflows, use cases, need to knows, including containerized environments and how to execute an unsupervised, long-running job. And then we'll have a tutorial, lay out the objectives, and we'll do the hands-on portion. So UWIT provides research computing services to UW faculty, students, staff, and affiliates. And our services include high-performance computing, so the supercomputer Hyak Klone, which is our third generation of the Hyak supercomputer. It has a mix of CPU-only machines or computers and GPU computers. And then we have our new GPU cluster called Tilikum. We also provide on-premises data storage options, COPA, S3 object storage, low data archive, so that would be for your data sets that you don't need to look at very much, very infrequently used, but you have to back them up. We also are a reseller of cloud computing services from AWS, Google Cloud Platform, and Azure. So if you are going directly to the vendor for those services, you should let us know and we can make sure that you have an account that is under UWIT, so you get our negotiated discounts, and you're also covered by our data privacy policy with these vendors. We also provide secure computing options, and we do computing consulting. So if you're just have a project, but you're not sure which of our services will best fit your needs, then you can come and talk to us. Today we'll be using Hyak Klone. This protocol is possible to replicate on Tilikum, but we don't have it integrated with our Open OnDemand graphical user interface platform. So we'll be using Hyak Klone for the demonstration portion. But in the GitHub repo that I've shared with you all, there are instructions for using SSH port forwarding to use RStudio in a graphical manner with Tilikum. So Hyak Klone is a HPC or high performance computing cluster. It uses a condo model, meaning that if your lab group purchases hardware to add to the cluster, then you have priority access to that. It's a shared resource for you and your lab. Any of the members that you add to the group, you just have to compete with each other for resources. But your queue wait time should be very, very short and reasonable. If you have a queue wait time longer than a half an hour, then you should let us know. It is attached to storage for computing, and we also have community idle resources. So just by being part of the Hyak ecosystem, you can schedule your jobs on our checkpoint resources, which are not being used at the moment for the folks that added the hardware, so you can schedule your jobs there with some limitations. And by my December 2025 count, we have over 37,000 compute cores attached to this resource and 864 GPU cards. Just a brief mention of Tilikum. It's our new GPU cluster. It is ranked in the world's fastest computers at number 185, and in higher education in the US, that puts us at number 7. It's also number 51 in power efficiency, and it supports all domains. So it has a very flexible pay-as-you-go program. So if you are thinking, I want to explore GPU computing for my portfolio, we offer your first 100 GPU computing hours for free, so you can test it out. All right, our team offers user support. We have a help desk, so you can email help@uw.edu, or you can use the support form. This PowerPoint presentation is shared on the repository, and so if you click on any of the underlined text here, that will take you to the page that supports that form or the calendar as shown here on the screen. We have office hours twice a week we hold office hours. Once is on Zoom on Wednesdays at 2 p.m. and on Thursdays at 2 p.m. we are here in the eScience Institute in the lounge area where you can find us to have one-on-one support in person. So this afternoon I will be here again holding office hours if you want to continue asking for help with R or any other questions that you have about Hyak Klone or Tilikum. We also have our regular training opportunities. So managing Python environments with Conda and Jupyter is our next training on Thursday, March 5th, 1 to 3 p.m. All of our trainings are recorded and available after the workshop. And you can find our events on the events calendar. We also have a mailing list. So a little bit about documentation. If you like these workshops, that is great, and this option is always here for you, but you can find self-help guides on our documentation website, as well as monthly blog posts, which will give you any updates about the cluster or opportunities coming up. And then we have our section of learning resources where we have short how-to videos or links to our full-length trainings like today. If you're a student, you should know about the Research Computing Club. Through the club, you have access to Hyak Klone with a free priority account. And that priority account is attached to 26 compute nodes, so CPU-only nodes, and 24 GPU cards, or servers that have GPU cards. You get that priority scheduling. So this is, if you're new to Hyak, it can be sometimes frustrating to wait on the community idle resources. Like I said, their wait times vary and there are some limitations. And if you're a student, you should definitely be taking advantage of these accounts provided by the Student Technology Fee Committee. And there's also storage for you there, dedicated. We also have a cloud credits program, so you can apply for $500 of AWS credits, and we'll give you guidance and troubleshooting on using that. It has a Slack community where you can get help from your peers, and you'll be notified about all of our events and any jobs or fellowship opportunities that come across our email threads. We also cross-post them there. And every year we have special events, a hackathon, and last year we did an AWS Game Day, which was a really fun coding competition. In this year, the hackathon is going to be hosted by IBM, and it's going to be a quantum computing hackathon. So be on the lookout for that. It's coming on May 14th. All right, so let's get more into why we're here today with a focus on R and RStudio on Hyak Klone. So why would you find yourself at this place where you need a supercomputer to use R and RStudio? You can install this software on your personal laptop and run your jobs there, or run your analyses there using script and all of the features that R and RStudio offer. But maybe you find that your job is long running, it is computationally intensive, it is outgrown what your laptop can do. You require larger amounts of storage or memory to run those jobs, and you are just ready to reclaim your workspace. You don't want to dedicate your laptop, which you need for other things, to just be open and running hot on a data analysis. So that is why people approach us about using R and RStudio on Klone, so that's why we're bringing this workshop to you today. The benefit is that you have access to these powerful computing resources. We have a job scheduler. This can allow you to set up your jobs in not just your R script, but in a script to submit that analysis to our job scheduler Slurm, where it can be executed as a batch job and you don't have to be supervising that. I'll show you how to do that today. In the repo, there is an optional side quest to have that set up to email yourself when it's done as well. So you can be on top of doing one activity and moving right on to the next. But there are some things that you need to know. So Hyak Klone and also Tilikum are Rocky Linux systems, so operating system, and we have our Slurm job scheduler. So Slurm stands for Simple Unix Resource Management Tool, but it is actually not simple. It's it's gotten quite complex, but it's a really powerful tool that allows you to submit your jobs, and in the background there's kind of like a 3D Tetris finding the resources for your jobs in the most optimal way that allows the cluster to continue to be a shared resource. One of the best things I think about Hyak that we've brought to you just in the last 2 years is Open OnDemand. It is a graphical platform, and that is our main method for loading up your Jupyter notebooks, RStudio, which we'll talk a lot about today, and we also have VS Code there. So if you need that, any of those, I would recommend to, we won't go over all of those things today, but pay close attention to Open OnDemand and continue to investigate and play around with it if you need it for these other platforms as well. We use containerized environments sometimes for Klone, and especially for this workshop, containers will be a star of the show today. R is exclusively given on Hyak Klone through containerized environments. We use an Aptainer runtime. We have other workshops that focus solely on containers, so if today you find that you have more questions or want to go more deeply into that, you can check out our learning resources and find some how-to guides there on moving through those protocols. We also have LMOD modules, which is another way that we're able to provide software that users don't have to have administrative access. And for your Python environments, we recommend our Conda module. Those options will be really the focus of our March 5th workshop on Conda and Jupyter. But like I said, we have our Open OnDemand platform, so just as you're used to seeing RStudio on your laptop, it looks exactly the same through Open OnDemand, but you know that there's a supercomputer behind it. You can ratchet up the memory resources and have the larger storage available to you. So the last bit of need to know is our software policies. So Hyak Klone is a shared research environment. We support a baseline software stack. The most common libraries and software that most of our researchers need. And then we kind of keep it as basic as possible so we're not taking up too much storage on the nodes. But the really important thing there is that we're not giving root or sudo access to any researchers, so there are other methods that you have to learn to be able to manage your software environment. So since it's your research project, it's your responsibility to make sure that all of these things are working as they should, but of course report to us and let us know if anything is not working. I'd say if you are stuck on something for more than a reasonable amount of time, I would say an afternoon, and you're still stuck, please reach out, use our support intake form, email help@uw.edu, and that will open a ticket support, and then our team will be able to work on this together and get you the best solution. All right, like I said, Hyak Klone is an RStudio on Hyak Klone are provided exclusively through containerized environments, and our software policies are the reason for that. So let's go more into containers. What is a container? So a container is a lightweight, isolated software environment that encapsulates the application along with the dependencies and runtime settings needed to run that on a shared high-performance computing cluster or anywhere else. So for RStudio, maybe if you have seen, sometimes even on your local computer, if you update your version of R, everything is broken then after, and you have to do a lot more installs of your packages from scratch. Updates can be very messy, and containers make this more flexible. And the main thing is that in practice, containers give you control and consistency without needing admin access to install the software into your RStudio environment, and you can do a lot of customizations there. Right, I already kind of said this, but containers are a consistent and reproducible way to package and distribute and run your software across different computing environments. So if you go on to another university or you get an opportunity to use one of the national labs or NSF access computing resources and they have Aptainer runtime installed, you can also take that container that you have customized and worked on and just kind of plug it in to that computing environment, and it will still be compatible, and you shouldn't see problems with dependencies. Another thing is that it allows you to have your RStudio packaged and installed as a single file, whereas I don't know if you've kind of gone into your computer and seen all of the files that are associated with R environments and packages, but it can be quite a lot of sprawl. And so this cleans that up a bit. So folks on our clusters find that it can be a nice way to have a clean workspace. So when will this appear? When will this containers appear? You might have packages in your R environment that don't have a lot of dependencies or that have very common dependencies, and you can install packages and it will install them into your personal R library and there's no issue. But there are interactive installs with install packages that will fail. And this is because those packages usually require system libraries or OS, operating system level dependencies, that you don't have access to install in the container because it is a read-only environment and you have to do a little bit more work to get that going. So the key is that the container itself, just installing packages, it has a mounted R library. We'll see this, the demonstration will make it more clear. There's a mounted R library with those easy to install packages are going to be installed, and they're accessible to that container from the first install. So those packages are easy peasy, you'll be good to go. But you might run into a package as you're exploring things that has more requirements, and then you're going to want to use a container definition file, rebuild that container, install the package there so that those libraries are brought in at build time rather than run time. So we'll practice this. Right, so I just said this, but you're going to need to rebuild the container, install the packages at build time. And are these hard to build? Yes and no. So it can take some time. If you have a very complicated workflow, you might want to reach out to us and get some tips before spending too much time kind of toiling away at getting this to work. But the Rocker project, which is like R on Docker, it's this organization that has built trusted R images, and it's containerized in R environments that are very common for researchers. They have the R base environment, RStudio server, plain. They have Tidyverse, which is an awesome graphics package, but it includes a lot of dependencies that just installing that yourself would take a very long time. They've already taken care of that for you. You use that as your baseline container, and then you can install your packages with the container definition file. And another benefit of that is your container definition file is basically documentation for yourself later on that says, this is exactly what is in this container. I can use it over and over again, and it's not a mystery. I have to use containers and have to help people with RStudio containers for my job now, but the reason why I became interested and think that this is the best way to go is that I used to be a postdoc in biology here at University of Washington, and there was a paper that I ran across that was a full R workflow on using mitochondrial DNA and making a phylogenetic tree from that, and I really liked the graphics that were output. Of course, there are many different ways to do that, but I was an R user, am an R user, and that was my comfortable medium. And I, just tried to install things into my own local version of R, and just failed because this paper was only 3 years old, but a lot of those versions were not compatible anymore. And so I decided I'm going to learn containers, and I found the version of R and the container that could work as a baseline and just started installing all of the packages that they recommended, and I was able to replicate and containerize their environment. And that allowed me to make use of that workflow that I was interested in. And I think some of you might run into this, that your dissertation work is going to be, you're going to develop some of your own tools. And containerizing that set of packages in that R environment will make your research reproducible for you down the line, but also will allow others to take your workflow and apply it to their system. All right, and then the other thing that we're going to talk about today is unsupervised R jobs on Hyak Klone. So there is a function called the RScript function. You can use it to execute a single R expression as like a one-liner, and we'll do that when I'm talking about how to install packages into a container. But you can also submit an entire R script that will just run through top to bottom on the command line. And this is, I think, the recommended way to take you from this interactive exploration of your workflow into production level. Now you have to apply this workflow to many different samples. You have to apply this workflow across different projects. And you know that that job is going to be running a long time. This is the best way, and we'll get into it. All right, any questions before we kind of turn the page into the next section of the workshop? Okay, so what we're going to do for the rest of the day is that I'm going to walk through the training materials. They are available in the GitHub repository, so this is the link, and the link was sent in the email. It's also written on the board here, and I think Samaya pasted it into the chat. I would recommend that you have this repository open in another tab on your computer so that if you miss something that I'm typing, I'll try to keep a very nice pace, and if I'm going too fast, someone just shout it out. But there you can find the commands that we're going to use. I've tested them, and they should work. Just copy and paste. If they don't work, again, just stop me, and we'll troubleshoot from there. So what we're going to do in the, I should have said, if you like better to do the tutorials on your own, that is also available to you. But I'm going to get through just as much as possible for folks that want to see things and kind of have the improv explanation of my thinking behind these examples. So we're going to learn how to launch RStudio server on Hyak Klone using the Open OnDemand platform. We're going to learn how to manage R package software using a R environment configuration file called the .renviron file. We're going to use pre-built R and RStudio containers on Hyak Klone. We're going to build custom R containers with additional packages and dependencies that are needed. And then we're going to, I guess, this is not quite right. We're not going to run a long-running job because that is not tutorial friendly, but I'm going to give you an example of a job where you could adapt it for your long-running process. And that's going to use the RScript function, your custom container, and our job scheduler Slurm. And then when you get a chance, please also use our feedback survey to give us some feedback about how this is going today. We're constantly trying to improve this and bring workshops that you're interested in. So need to knows about today's training and the access period. So like I said, you will be able to complete this training whenever you want. I've gone through if you registered, I've gone through your net IDs and I've added you to the UWIT allocation, as well as whatever current allocations you already had. And if you were not previously a user, I've also signed you up for a demo account. So your access to the UWIT Slurm account will continue until Monday morning. So if you don't have access via a student access or one of your labs, this will give you an experience as if you're a priority user on the cluster for a little bit of time, so you can test out the workflows that are presented for you today. And then after that, if you're not part of another lab or you haven't applied for student access yet, then you still have your demo account, which doesn't expire, and you can go through on your own time and test these things out as well. And you can just continue exploring Hyak on whatever workflow is of your interest. So this tutorial has been designed as some introductory concepts, that are in the repository as different sections, presented as different sections. And then there's a task that brings together these things. All right. Any questions before we dive in?
We have a user who asked if you'll also be talking about parallelization.
Not this time. The parallelization, the one thing I would recommend is that that would be combining the job arrays from Slurm, which is a tutorial on hyak.uw.edu, and the R script function with Slurm. So if you look at the the Slurm scripts to submit an R script with the R script function, there are some things you would want to change about your R script so that it is taking variables from the outside, but you'd be able to apply that many times if that's what you need to do. But we're more on the basic side here of getting things set up and setting up the environment today. But good idea for a follow-up. And like I said, this presentation is available as a PDF on the GitHub repository, and here I have just tried to find all the helpful resources that you might need. There will also be a follow-up email when the video is available so you can review this content on your own. All right, so today we're going to be starting in the terminal. We'll be coming back to Open OnDemand in a second, but since I know that some of you are brand new users, one of the requirements to using Open OnDemand is that your home directory has been generated. And so if you go to Open OnDemand platform and you see that it basically tells you to go and do what I'm about to do if you haven't done this yet. So we will log in. Your first login is required before using Open OnDemand. So the command is SSH, or the secure shell login, your netid at clone.hyak.uw.edu, where it will then take your password. The password is your same password for all of your UW services. And it will ask you for your two-factor authentication method. And then you are in. I'll just scroll up here again for a second to show you should use your UW netid and SSH with this address to log in to Hyak Klone. If you have too many failed login attempts, which does happen sometimes with passwords, then there could be a 1-hour IP block. But there are several reasons why you might not be able to log in. And if you do get frustrated about that, just let us know by opening a ticket and we can help walk you through. All right, so when you get started on Hyak Klone, you are in a storage space called your home directory. Everyone has a home directory. The path to your home directory, if you use the print working directory command, or pwd, for everyone is mmfs1 home, and for me it's Finch kn because that's my UW netid. Your home directory only has 10 gigabytes of storage available to you, and if you hit the limit on that storage, you are basically prohibited from doing anything else. So it is one really important job when you're a Hyak user to protect that home directory limit and reserve it only for configuration files. Really no data sets should go in there unless they're very small. Keep it as clear as possible. And if you do run into that limit and you don't know how to fix it, just let us know. With that being said, we are going to set up a working directory for our tutorial today. And that directory is going to be set up in our scrubbed storage, or our temporary storage. This storage is free and open for the community. It has an automatic erasure policy where it will erase files that are inactive or haven't been accessed or modified in 21 days. So your permanent code bases, you would want to have, if you can, in your home directory if you have no other choice, but you would want to manage that in your lab's dedicated storage, student dedicated storage, or we can talk about other methods for you at a separate time offline. So you're going to go to gscratch scrubbed. That is the path to our free community storage, but is erased. We can call it our scratch storage for today. And there you can make a directory for yourself using your UWNet ID. So I'm not going to make a directory because I already have one. But if I did that, I would use the command this way, mkdir finch kn. But since I already have one, I'm just going to change directory to finch kn. And there's nothing in here. I emptied it out after my testing. Is everyone at this point? We have a directory which we can use for our scratch storage for today, since we're just learning. But we're going to do a few things in here at first. First, we're going to make a new directory called R using mkdir. So that makes our R directory. This is going to become our R library. This is where any of those easy to install packages will be installed. It is okay to do this. You don't have to install everything in the container, and you probably will decide not to. It's always good to have your personal library configured so that by default, R will want to install those things in your home directory. And like I said, you have a very strict limit. And if you hit that limit, you're going to be upset because you have to take care of cleaning up storage. So this is what we're going to set it up and configure it, but this is where your R libraries are going to be installed. We're also going to clone our GitHub repository. And if you do have the GitHub repository open, then you should go to the page 00-prereqs.md, where you can find the git clone command that I'm going to try and slowly type into the command line. If you wanted to copy that, you could find it there. So it's git clone https://UWRC for UW Research Computing, and then R _ RStudio _ tutorial.git. It's also written there on the board for those of you in the room. Oh, that says .gr, so that wouldn't work. Okay, .git. I forgot some stuff here. Sorry, guys. First, you have to do github.com/. So I'll read it out again. Git space clone https://github.com/UW _RC /R _ RStudio _ tutorial.git. And now if we ls or list our directory, we have two directories now. We have our R directory, which will be our personal library, and we have our RStudio, all of our files for this tutorial today. So let's go ahead and go into our R and RStudio tutorial. If you saw that I just typed unbelievably fast, well, it's because you can do a quick tab complete, which removes errors in just typing. So if you go in there and you list the directory, we see that we have all of our markdown files, which are the sections for the tutorial today, and some other files that we'll look at a little bit later. But one file that is missing that was too big for me to put into the GitHub repository is our test data from our Slurm accounting database, which will come up later. It's just test data that I had lying around. It's about our checkpoint or our community idle resource jobs. So we're going to copy that data from a shared location on the computer already into this directory. So we're going to copy from the software directory, containers subdirectory, R subdirectory, and it's called saccount. So if you just start typing SACC, and then you'll do dot to say I want to copy that file from there, from that full path, to here. Didn't anticipate that it would take too long, yeah, but it is 1,000,000 lines. Okay. So now we can see all of our files that we have available for this tutorial today. And one directory above this, we have our R and RStudio tutorial directories. So the whole point of this is just to get our materials ready to do the rest of the hands-on activities. Any questions? Anyone get stuck?
Is the path of the CSV in any of the Markdown files?
Yes. So it's on the same one. It's in the section called Scrubbed Storage, our tutorial workspace, and it's down right before the section called Creating Your .r environ file. Like 2 lines about that.
Prereqs.
Oh yeah, in the 00-prereqs MD. Yep. All right. Keep going. Okay. So next we want to set up, like I said, our R environ configuration file. This way you always by default are storing your packages into your choice of where they should be installed and not in your home directory, which is where it will want to install them by default. So we're going to change directory back to our home directory, and you can do that by using CD and the little tilde symbol. That's a shorthand for taking you back to your home directory. And we're going to use a one-liner. This is another one that you might want to copy and paste from the GitHub repository, but I'll go ahead and do it. You're going to use the echo command. Basically what this command is going to do is you're going to set a variable called R_libs and put it equal to the path to the R library that you just created in your Scratch storage. And then you're going to output that variable directly into a file called .renviron. So we'll do it and then I'll show it. So we're going to do single quote, capital R_libs equals double quote / /gscratch / scrubbed / here you can do your username, but you can also use the variable user in the following manner: / R double quote single quote append to or redirect into our home directory. We're going to have a file called .r environ. All right. So it's echo space. Oof. It's like a lot of. Anyway, I'll go through how you can make this without the one-liner. I just thought the one-liner, if you're able to copy and paste, would be the fastest method. Okay. So now to be able to see that that worked, you need to do ls-a, because when you start a file with a dot or a directory with a dot, that means that it is hidden from your normal list command. You have to use ls-a for all to list all files. So now I can see I've got a lot of junk in here because I have to test all the software. But here it is, R environ. So if we copy that and use the concatenate command and paste, or just type cat space dot capital R environ, then you'll see, oh, I must have already had this here. So I'm going to go in and actually edit this by hand. So if you didn't have access to the one-liner like I just made, you can also just use a text editor. I like Nano because it is friendly to me. R environ. You can open this file and you can edit it by hand. If you don't have this file existing already, you can also start the file by just using Nano. And if this is here twice, it really probably wouldn't hurt anything, but I just don't like how it looks. So I'm going to delete that with Control K. And now I only have that in there once. It should, for you, it should have your username here and not Finch KN. Is that making sense to everyone? So that's the path to the Scratch directory where your R personal library is going to be. And now I'm going to Control X to exit, and it's going to ask me if I want to save that, and I'll use Y to say yes. And it's going to ask, is it okay to save it as this file name? Yes, with return. So that part is set up. So what you've done here is you have protected your home directory from being the default location for your R packages. R packages can be quite large sometimes, and they are necessary and needed for using them across your R sessions, but we don't want to pollute our home directory. Does anyone have any questions about the steps that we have just taken? Yep.
So the R environment file is in my scrubbed, but how did I just get to my home path? Like I'm in my home directory and I had nano.
Yeah, so before we did that, we did this step of when we were in our scrubbed directory, we did change directory to the little tilde, and that took us back to our home directory.
So my R environment is in my home directory.
Yeah, it should be. So if does your command prompt look like mine where it has the little tilde right here? Okay, that means that you're in your home directory. So this, this area on your command prompt, it changes when you change directory. So before, when we were in scrubbed, it had a different path. So it's giving you a hint of where you are in the file system. So for example, if I wanted to go, see how I have this printed here? I could go to this path. So I could change directory and go to my R library file and now see it changed, and it's telling me like now I'm here. Like my shell is looking into this directory, which is at this location. And then if I change directory back to my home, it changes again. And I can tell that I'm in my home directory. This is where all the home directories live.
But when I hit LS, I don't see R environment.
Right. So the ls, so because it's a hidden file, you have to use ls-a, which will show you all the files that start with a dot. So let me clear my screen. So if I just ls, then, well, okay. When you do ls-a now, do you see your R environment file? Okay, good. All right. So the thing is that R and RStudio, they're going to look into your home directory all the time. It's actually not just R and RStudio, it's most of the software that you use on Hyak Klone. It's going to look into your home directory and it's going to try and find if you've set up any of your personal preferences on where things are installed. And this is one thing that we're doing with the R environ configuration file. We're saying we don't want our packages to be installed in our home directory. We want it specifically to be installed in our gscratch scrubbed user R directory. So one thing to note, do you all have your dedicated lab storage, or do you have a student account? I think you're eScience, you have student accounts, or which lab are you part of?
We're in Harvey Lab.
Harvey Lab? Okay, so CoEnv?
Yes.
Yes, okay. And then your PI has Telecom, right? So, okay, anyway. So you all have dedicated storage somewhere. So I would recommend that your homework assignment for after this is you might want to reset that R library to be in your dedicated labs storage instead of in scrubbed. But for this tutorial today, we'll be setting it up in scrubbed just so we're showing you, and you can clean it up at a later date. But if I were still a postdoc in the Wasser lab, I would use nano, and I would go to my .renviron file, and I would edit this by changing this location to Wasser. Finch KNR, like that. So I would change this location. If you're a student user, you would want to use STF. For coenv, you would want to use, which I don't have access to coenv, but you would look like that with your username here. eScience, same thing. Okay? But for today, scrubbed. All right? So that's your homework assignment, to find out on Hyak where you should store all of your data so it doesn't magically evaporate. You should leverage scrub storage. You should. But you should just remember that you have 21 days and you should move that into a different location after you've gotten your results generated or whatnot. All right, the last thing that we're going to do is that in Open OnDemand, which is the next part of this, we want to have a shortcut, a clickable shortcut in our home directory that takes us into our scrubbed or our Scratch storage, where we have stored our files and everything that we're going to use in R. So this is also in the GitHub repository. It's instructions on how to make a symbolic link to your Scratch storage. The command is ln-s/gscratch/scrubbed. And this time we're not going to go directly to your R directory. We're going to go to the top level of that. So you're just going to use either user, the variable that is equivalent to your username, or you can put your NetID. Either way. And next, the rest of the command is you do a ~/scratch. So this shortcut is going to say scratch. It's going to be a little clickable. We'll see it in your home directory. I'll show you how you see it in the command line, but it allows you to quickly jump from your home directory into your Scratch storage where you will set up your R files for today. And I guess the other homework for today is that at a later date, you want to set this up and again, change to your lab's dedicated storage. All right. So I am actually going to delete this because I already ran it. So if you have run that command, now if you ls, actually do the ls, the long format, you can see that you have a little light blue. Sorry, the contrast might not be very nice by default. But you have a Scratch storage, but it shows you what it's pointing at. It shows you the true path of that shortcut. And I also have another one that I made before to go to our Hyak team storage. So that's why I have two. All right, one important thing is that if you have done this incorrectly and you want to change things, you want to later, when you're doing your homework, you want to set it up for coenv dedicated storage, you can rm scratch, if you spell it right. And that will only remove the symbolic link. Just note that it does not delete what is at the destination. So you're just deleting the symbolic link or your pointer to that dedicated storage. You're not deleting the dedicated storage, so don't be scared. Okay. All right, with that, we are set up to then move into the next part of the tutorial. Do we have any lingering questions? Oh, I see a lot of messages in the chat. Let me just see. Yes, Hyak is available to affiliates as well. You just have to have a UW NetID. But if you, oh, sorry, Samari already answered. Nice one. Okay. Yes, so thanks, Matt, for coming to our last tutorial. So if you still have your Linux fundamentals directory there, you can delete it if you want to keep things clean. You might see it hasn't quite been 21 days, I don't think, since we had that training. So it's only been 2 weeks. So after a while, you will see that files will start to disappear from our 21-day erasure policy. So you can delete that with the rm-r because it's a directory. All right. So I'm now going to move into the next page of the GitHub repository, and I'm looking at the one called 01-OOD-RStudio.md, where we're talking about Open OnDemand. So if you are outside of this room and away from the UW campus, this is the point where you need to be on the VPN to access this. So hopefully you set up your VPN before today and you're able to follow along with this. If not, you can try it on your own after. We'll just use Open OnDemand for a quick show of how to get RStudio started, and then some of the next sessions will be more intense, I guess. So I'm going to open up my browser. So from the repository, I have linked Open OnDemand. So if I go into this section that we're working on right now, the link is https://ondemand.hyak.uw.edu. I've obviously gone there quite a bit, have it bookmarked. And this is what it looks like when you get to the on-demand dashboard. So since we have all logged in for the first time, and since we have all set up our VPNs, we are able to get to the on-demand dashboard without a problem. By default, we just post our Hyak blog updates here as a stream, so you can quickly jump into those. What we're going to do at first is to use the interactive apps drop-down menu and find RStudio. And yours is going to look a little bit different than mine. Since I am a developer for our team, I have this sandbox application available to test out new versions. But yours won't look like that. But what you will see is the rest of this, which is you have your accounts available. So like I said, I'm part of UWIT, as you all are. So today, go ahead and check UWIT, and you might have some other accounts here as well. We've got several partitions available to us. Your choice is to choose between compute, compute big mem, or CPU G2. So I'm just going to use compute. These are all very similar resources. And instead of custom, we're just going to start out with the tidyverse container. So these containers here at the top, the ones that say rocker / whatever it is, these are containers that are maintained by our team. So they're your choice if you want to use them. Later, we'll look at what happens when you use the custom container option. And then your library user path is going to be put in here. So this is just like what we set up with our R-environ R-environ configuration file. But we're also just going to do the same thing here for extra safety, since we've been talking about how important it is to manage storage. And you can use it with the user variable here. So you can replace this with your username, or you can input it exactly as is shown here. All right, next we're going to do the rest of the boxes as I have shown here. So tasks is the number of subtasks or nodes that you have sometimes, but usually R is only set up by default to use one CPU. You have to write into your code if you want to use multiple CPUs. It will not distribute that work unless you instruct it and set it up to do so. But one thing that you can ratchet up quite nicely is the memory, as long as that resource type has the amount of memory that you want. So for today, we'll just use 40 gigabytes, probably 20 is enough for this. And we're going to start our job just for 2 hours. We're going to end it before that 2-hour point is reached. But if after 2 hours you have not ended your job, it will close itself. So we're going to launch this. What that form did is it took our resource requirements and it basically made a job request to the job scheduler Slurm, and now it is scheduling our job. So the job ID for this job is written here in the parentheses. Gives you a little bit of information about the job. My job is already ready. I can see that it has been assigned to a computer called N3319. Some of you might also be on that computer or a different one. And it shows me my time. And then this link goes to a lot of the more in-depth logs. So if you have some like very strange behavior that you're seeing when you're using RStudio from Open OnDemand and you want us to know about it, then don't delete your job after you're done using it. If you keep this session ID, we can go and investigate with kind of all the tools in our arsenal. All right. And then it starts up. It jumps out when you press connect to RStudio. Oh, I must have not closed this gracefully. We'll go over that. But it opens up in a new tab. If you have any strange messages, sometimes I just like refresh. So did everyone's job turn to green and say the running status on their interactive session? Not yet? Okay. Did you use the UWIT account? Okay, let me just really quick check and make sure. Okay, good. So just because I know some of you are beginners, you can monitor the Slurm queue with SQ. That shows you the entire queue, be warned. All of the jobs running and all of the jobs waiting to be run. But if you want to just look at the job for yourself, you can use this or this in your case, so that would go to your username. And now I can see that my job, like I said, which is here running 328, is here running 328. It's in the state of running, and it's been running for this amount of time on this node. So you can look at your jobs that are running. So if I wanted to, I could look at all the jobs running on the UWIT account. So I see that a lot of us are following along very nicely. Thank you. All right. So that's just a little aside.
Hey, Kristen.
Yep.
Looks like one user is having trouble getting connected to Studio.
Can you hit refresh? Yeah, it might be your connection, unfortunately. Yeah, sometimes that happens. Everyone off campus is taking longer to load. Yeah, just refresh if it's taking a while. It's not perfect. In this maintenance, so we have maintenance on Hyak Klone every month on the second Tuesday. This Tuesday coming up is maintenance, and we're attempting to do a big update from Open OnDemand version 3 to Open OnDemand version 4. So I'm hoping to see that there will be some improvements. It does also enable more accessibility features for the Title II regulations coming into place. Okay, moving right along. It looks just like what you'd see in RStudio on your local computer, and like I said, you're in your home directory. So I have too much stuff in here, but I do have my quick clickable to Scratch. Remember we made that? I can also see my R-environ file is here, but let's go ahead and click on Scratch in Files, and it takes me from my home directory directly into our Scratch directory, which we made up, which contains our RStudio tutorial files and our R file, our R libraries file. So if we click in there, we can see this stuff. Later, we're going to open up this script. So wherever you set up your quick symbolic link shortcut is where you want all of the stuff that you're going to use in RStudio to be. You want all your data sets to be in there. You want all of your scripts to be in there. And as you know, if you're a R user, you need to set up your working directory. And we'll go over that later. But for right now, I just wanted to show that that is the recommended way to set up your RStudio container, or your RStudio connected to Open OnDemand and be able to use RStudio interactively on Hyak Klone. So we're going to come back to this, but we're going to jump into your customizing containers tutorial and also demonstrating some of the concepts of behind a container, where your packages are installed in the next section. So for now though, we want to gracefully close our R session. So we'll use this little button up here in the upper right, which is a little orange power button. And then it tells me that it's quitting my RStudio session, or my R session, and that has ended. So I just close the tab, and then I can delete my job to give back those resources for all of us to use. They go back into the pool of available resources. Okay. Any question on that session? It's just a quick kind of look at how on a daily basis, or whenever you're doing work, you would use RStudio. All right. So I'm going to move into the next section, and we're going back to the terminal. So the next section on the GitHub repository is a lot of background information about R containers, but I ran over that in the presentation, so you can skip into 03 custom r-containers.md, and that will be where you can find your copy and paste commands for this next session. So let's go back into our scrubbed directory, our scratch directory, where we have our files set up. We're actually going to go directly into the RStudio files. So we're here. So if your path, when you do print working directory, is similar to gscratch scrubbed your UWIT ID and then the directory, then you're in the right place. In the next steps, we're going to be running a container without using RStudio. So we're going to be running a container from the command line. We're also going to customize that container. And we're going to talk about need to knows when you're using containers. And then we'll do an even more complicated customization for a container. And that's the container definition file I think you all should start with as your template for when you're customizing your own container. Okay. So to work with containers, it is always recommended on Hyak Klone that you switch from the login node to one of the compute nodes. So to do that, we're going to allocate a compute node for our job, our interactive work now. So we're going to use the command salloc --account equals UWIT -- partition equals compute, or you can put compute -big mem or compute or CPU -2 -- time equals 2 hours -- mem. This time let's do less, let's just do 20 gigs. So things to know about this is a slurm command called salloc or slurm allocate. You want to put your account if you're part of multiple accounts. So after this is over, if you have your own dedicated accounts, you'll want to change the account to be whatever that is. Could be coenv, eScience, STF. And then choose from the partitions that you have available to you. I'll show you right after this, but go ahead and execute this command so that we get our jobs started. And then mem, or memory, that you're allocating for your job is the last part of this. And you always want to include the units because it is in megabytes by default, which will give you very little memory. Okay, so now I see that my location, I'm still me, but instead of being at the login node, I am in this host, N3206. You see it's a different host than last time. And I'm still inside of my tutorial files. So what I've done is I have changed into a compute node where I can do some work. So how do you know which partitions or which accounts you have access to on Hyak? You can use the Hyak alloc user command, which will show you a table of the accounts, partitions that you have available to you, as well as the idle resources at this moment. And it also tells you a little bit about the usage. So it looks like it is not updated because my job is running here. Oh wait, yeah, it is. So 12 of the CPUs in the compute partition are allocated, probably for those of us here doing this, and nothing else. So that is how that works. You probably have a very many different things available to you in your Hyak alloc command. All right, so what if we want to get a container from Rocker? Let's say that I don't like the containers that are available by default for me from the Hyak team on Open OnDemand because it's an old version of R and I need a new version. Well, you can pull that from Docker, which is a container repository where the Rocker project Docker containers for R are stored and available to you. So we're going to pull a container from Docker using our apptainer runtime. I'm also going to I'm going to apply the time command. I like to do this because after it runs a command, it tells me how long it took to run the command. But the command is apptainer, which is our container runtime, pull to pull from a repository. We're going to pull from Docker. We have to do :// We're going to pull from the Rocker repository. And we're going to pull r-base for just a base container with R, no bells and whistles, very clean. One thing that you can do is after you have this command, if you go to the Docker Hub page with the Rocker containers, you can actually pull any version of that container to Hyak Klone by adding the tag at the end. So if I wanted to pull R-base version 3.0 or something very old, you could do that. By default, if you don't specify a tag, it's going to give you the latest version. And this takes about 2 or 3 minutes and has a nice status bar. Have we all used containers before at all? You have? Okay, good. Yeah, cool.
You actually helped me build a container.
Oh, right. Okay. Excellent. Was it the really complicated one? Or okay.
It was complicated for me.
Yeah. Okay. Well, good. Well, this part will help you set up everything correctly so that you don't hopefully run into any problems. This R container, like I said, is a very stripped down container. I usually, if I'm building a custom container, helping someone build a custom container, I always start with the tidyverse container because likely they might need some plotting. They might need to do some plots. And tidyverse also installs like dplyr container, which is great for wrangling data. So that's usually the one that I do by default because you get a lot of other dependencies, packages that are used by many packages in the R universe. So that's usually my go-to. We do have some groups that are using R for very complicated bioinformatics stuff. And I connected with a facilitator at Tufts University, and they made custom R containers for their users. They have a much larger team than we have here, but they were able to make a customized RStudio server container, which has a lot of the missing operating system packages or libraries that folks tend to need. And they also made a container that uses that one that is for single cell RNA-seq analysis. And so a lot of BioC manager containers, BioC manager packages are available in that container, and they took a very long time managing that and making this like very complete container. So I do, if you're using a lot of bioinformatics tools, I recommend that container as a baseline for what you're trying to do. If you find yourself in a place where your R environment is very complicated, you should reach out, especially if you start getting stuck on your container builds. But what happens when you're installing a library or a package in R is that it gets through part of it and it says error, cannot install because whatever is missing. Your first clue, or the first thing that you want to do, is just grab that error and Google it and find out what it is indicating. If you see that it's indicating, or that anything that starts with lib dash or something like that, usually it's an operating system library that needs to be installed in the Ubuntu operating system that R is most compatible with, or Linux. And so if you find out instructions for how to install that, that's something that you want to keep in the back of your mind. You're going to use those instructions to install that missing library and all of the missing libraries into your container definition file, and we'll talk about that. But Google is your resource for how to do that, as well as like CRAN is a repository for many R packages, and we'll talk about downloading those from CRAN using the definition file as well. Okay, so mine is done. Did everyone else's finish? Okay.
Kristen, we have a question about someone's asking if there are well time restrictions.
Yes, so on UWIT, so if you have set up your command similar to what I did, then you don't have the wall time restriction for this job because you are a primary user for the next few days on UWIT account. If you have a dedicated account, then you don't have a wall time restriction on your jobs. But if you're using the community idle resources through the checkpoint partition or CKPT partition, then you have a 4-hour maximum wall time, and on GPU jobs you have an 8-hour maximum wall time. So those are some restrictions for the community access only, or the free option for Hyak Klone. Okay, now that we got that done, we're going to go ahead and go into the container. So we're going to change our location from being just inside of Hyak Klone in our directory to going inside of the container. So we're going from the host's kernel into the kernel that is containerized R environment with RBase. And to do that, we're going to use apptainer again. Anytime you're using containers, you're using apptainer on Hyak Klone. Shell --bind, and this is critical, and I'll go into it a little bit more, but we're going to bind gscratch. So we're going to bind the entire file system. You know how we've set up our storage as gscratch/scrubbed, and all of your lab dedicated storage is under gscratch. It is the file system. The container doesn't know about it unless you bind it here, so it is a requirement. And then our container saved as rbase_latest.sif. So this is your command. It is on the repository underneath demo 1 on the 03 custom R containers page. All right, so what happened here was that my command prompt now changes to apptainer. This is the hint that you're inside of the container. From here, we're going to start R because we want to test out installing a package. So you just start R by doing R, executing R. So now we have a nice new version of R 4.5.2. And we can test out, this is not a very realistic example because we have to do things that are fast for this tutorial. But we're just going to test out installing package, install packages, open parentheses, open quotes, R, color, brewer. This is a package that doesn't have a lot of dependencies and just opens up some palettes, color palettes. It's going to install, and look what it's telling me. It's installing package, oh, where'd it go? I'll have to scroll up. Right here, it says installing package into gscratch scrubbed Finch KN R. That's exactly where I want it to install. That's where I told it with my R environ configuration file where I want it to install this. This, probably for our color brewer, is not very big, but for other packages can be quite large. This like downloaded from the internet tarball, which contains all of the files that our color brewer needs to be used. So now it says that it has installed this. It also installed some like temporary stuff in the temporary directory. That'll be deleted later, don't worry. So now when I use library R color brewer, I don't have any errors. I don't have any message saying that that library or that package is not available to me. So pretty simple. On R in Open OnDemand, as you're starting, just try and install your package there straight up, and it will install into your personal library, which can get connected to the R container. It's kind of mounted to it as well as the storage. If you don't have any errors, then you can move along just fine. But you might have some errors. So I'm just going to go ahead and quit R. And I'm not going to save my workspace image. I never do. And then we're going to exit the container just with the command exit. So I've quit R. I've exited the container. And now I'm back, still me, in the host where I have this job running. But what we want to do, remember that our R personal library is one directory above, so we can go into it. We can ls what's there, and now we have this directory for our color brewer where all of our stuff is installed. Let's just this command will tell us the size of it. This one's not in the repo. But the du-h-d, meaning depth 1, tells us the size of any of these directories. So it's not very big. But you could see where this could become a problem if you have a more complicated library. So it's installed into my file that is outside of the container, which is good. Let's go back into our R and RStudio tutorial. So if you should be back in your scrubbed directory with your RStudio tutorial, because that is where your container file is. So for the next command, if your container file is not visible to you, then you want to change directory to go into the directory where it is, which should be your RStudio tutorial directory. All right, so we're going to go into the container again, but just to demonstrate, we're going to show you what happens if you don't bind gscratch, obtainer, shell, and just the R base latest. So we're going to shell back into the container, but we're not going to bind gscratch, and we're going to see what happens. So now if I ls, I can't even see any of the files that are there. So for all of your files that you're using as input for your container work need to be bound with, or gscratch needs to be bound for R to be able to find them. Luckily in Open OnDemand, this binding is all happening behind the scenes. So you don't have to explicitly do this because we've done that for you. But if you're using containers interactively, you do have to. So we'll start R again. Now, if I look at by default what my library paths are, it should say, I mean, if we had bound gscratch, it would say as this first default library path, the path to our personal R library that we set up with our configuration file. But here it doesn't say that. It says a directory path that only exists within the container. And you can't find our color brewer. You can't load it. So that part fails. So if you have a problem where R is saying none of your packages are found, you might want to check if you bound gscratch, or if your personal library is configured properly. Okay. Does this make sense? It's kind of a very simple activity just to show you the importance of making your read-only container able to find files that exist outside of it. So I'm going to quit again. I'm not going to save my workspace image. I'm going to exit the container. And next we're going to customize the same container, but we're going to install our color brewer inside of the container during the build time. So it's always installed there. It's not dependent on my personal library. So again, you need to be in the directory where all of the files for this tutorial are. You have a file here called custom r.def. This is a container definition file. Let's concatenate this file to the screen just so we can check it out. It's very short. And this is actually just my command prompt that printed on the same line. So it's not in the container definition file. I'll go ahead and open it with Nano just so you can see a better view. Okay, so this is what the container definition file looks like. Container definition files always start with bootstrap. So this says, where is it pulling the baseline image of the container that you're wanting to use and install things on top of. This time we're going to be pulling that from Docker. That's where the Rocker containers are. And we're telling it from Rocker, same situation, from the RBase latest version of that container. And then in the post section, this is where you do all of your commands to install packages into the container, which can be useful. So if your R container has failed because it's missing operating system libraries, you'll want to install those operating system libraries here, which I'll show you next, but you also can install R libraries here. And we see our R script function. It turns this into a single line non-interactive command. So the R script function opens R and then it echoes into R this command, which is install packages R brewer, and it executes that for us. So this is basically a recipe file for a custom R container, which is going to, by default now, include R color brewer. Okay. Any questions about that? We're going to use our time command again and apptainer. But this time we're going to use build. And we're going to give this a new name for our container because it's not just RBase, it's going to be called RBase brewer because it has the R color brewer installed. .sif. So your container images always end in .sif and they are executable. So under our default conditions, they're printed in green. And then we give it our custom r.def definition file. So whenever you're building your containers, it's always apptainer build, the name of the new image that you want, and your recipe file. And since we already pulled the RBase file just a little bit ago, it is saved in our cache, so it's going to be a little bit faster, but it still takes a few minutes. Any questions?
For the .def file, if we wanted to include a bunch of packages, do you recommend a separate line for each of those installs, or combine them all to one install packages?
Either way. So it works both ways. So you can do install packages, package 1, package 2, or you could do all on separate lines. It's just up to you. Sometimes if you have a lot of, R gives you enough messages while it's installing things that you'll know probably where it failed. So you don't have to break things out unless you think you really want to double check some things. Just realizing that I shouldn't have deleted what I was testing yesterday because the next build takes a little bit longer to run. But there are things that we can talk about with it. I should have had that saved somewhere else and then like easy bake oven, like, oh, now it's done. Let me see if I did while this is running. I'm just gonna. For if we need it. But
we have another question in the comments too.
okay. Is this building a container that will install RBrewer at the beginning each time I load the container, or will it install it during building and it will already be installed in the container when it's loaded? Thinking about packages that take a long time to install. Yes, so you are correct. So this is building the installation of our color brewer into the full build of the container. So you won't have to, when you get into the container or when you use Open OnDemand to start your container, you won't have to install that again. It is already installed in there. And the other thing is that it's maintaining that version of R and that version of this package also in the container. For using your install via Open OnDemand, for example, the next time that you go into Open OnDemand, if that package is in your personal library, then you also don't have to install it again. So that is persistent across your R sessions, that your library will be there. Unless you have to reinstall it because you're using a container version with a new version of R, and then it tells you that that library is no longer compatible with your current version of R, and you have to fix that. Yep. Okay, so the container built. Awesome. All right, so to demonstrate that our color brewer is in there, we'll do the same thing again. Just to really drive this point home, let's go back one directory and let's go into R, where we have our library of our color brewer installed. And let's just blow it away. That has now deleted that library from my personal R library. But we're going to find out that it actually doesn't need that at all because it is already installed into the container. So here is my container file, and I want to start using it by shelling into it with apptainer shell, and then without binding gscratch. I mean, if you have other files that you want to use in R, then you should bind gscratch, but we can do it with or without. Since we're just trying to see if our color brew is in there, we won't bind gscratch. We'll open up R. We'll check our library paths. Like I said, it's just going to be a path that only exists in the container because we haven't bound gscratch, so it doesn't know our preferences for where we want that to be installed. But if we tried to load library R color brewer, we don't have any problem because we see that this library is installed in a path that only exists in the container. So we can quit R. Without saving. Without exiting the container just yet, let's just list this ls, this path at the top where it says that things are installed. And we see that our color brewer is installed in a path in the container. Path only exists in the container. So now if we exit and we try to list this path, the path doesn't exist. So the whole point of this was to say that there are ways to install R packages directly into the container. When you leave and it's installing in a path that only exists in the container. That's why I listed that path while it was still in the container. Leaving the container, we see that that path doesn't exist. It was only in the container itself. Does that make sense? Does the purpose of this exercise make sense to you? The key takeaway is that if it's in the definition file, it's part of the container. If it's in your R personal library, then you need to bind gscratch so that the container can find it. Okay. Moving on to demo 3 on this page. We have a bigger install of a container. So let's just go ahead and run this command so it starts to build. We're going to use time, apptainer, build. This one we're going to call rwlibs for with libs.sif. And then we're going to use this file, this container definition file, which is custom r-os libs. And just go ahead and run that. So again, we use the time. It's going to tell us how long it takes to run it. Apptainer build, we're giving it the new image name that we want, and we're passing it the definition file. So while that's going, I'm going to switch over to the repository so I can open the definition file and we can walk through some of the aspects of this. So the idea with this is I wanted to show you a build that is more complex. So again, we're starting with Bootstrap Docker. We're going to pull the tidyverse container, the latest version of the tidyverse container this time from the Rocker repository. And let's say that I have found out that so it's not, doesn't apply to our color brewer because we know that that one installs just fine. I actually think it's part of the tidyverse container. But let's say that we know that some of these operating system libraries are important for any other packages that you need to install. They need to be installed at the operating system level. So if you find that error on why your R package didn't install, and you Google it and you see instructions to install it include anything like apt-get install yes, then that is indicating, or any of these things starting with lib, that's indicating that's an operating system library, and it's not something that you can install in the container just via RStudio. You have to rebuild the container and install that at runtime because you're allowed to do that without sudo access if you're using the container. And then we're just, keeping our RStudio install there just as a placeholder because I know that you'll need that later. And then I also wanted to say we do have some other symbolic links set up on Hyak Klone. One of the major ones is that the path /gscratch that we've been using this whole time, it's actually a shortcut to mmfs1/gscratch. And so those two paths are equivalent, but this was before my time, they made the symbolic link so that they have a shortcut. It's just shorter to type in your paths, but it is equivalent. However, if you don't put these lines into your definition file for your RStudio container, if you plan to use it in Open OnDemand.
Yeah. So if you make your own custom R container, and then like 3 months down the line, you want to add a few more packages, and then like in the future, you maybe want to add more packages. What's the best practice for having, the same container, the same like R version, updating them all the way?
Good question. And thank you. I should have mentioned that in the repository. But you can also build from a local image. So Bootstrap, in this case, you would just use all one word local image, so no spaces. And then you would do from, and then you'd put the full path to that container. So you'd put /gscratch/cohen, whatever it is, and you would put that container, it would use that instead of pulling from the internet, the tidyverse container or whatever it is, it would use your local version of that container. It wouldn't have to rebuild all of those things, and you just kind of plop in the new things that you want. It saves a lot of time in the builds because maybe your container is already like very complicated, and then you can just continue to build on top of it.
So you have like your definition file that you're using to update. Should you like then make another definition file
Yes.
and want to update again? So excluding everything you've already updated.
I think so. I mean, you could add it, and you could continue to add to things on top of it, but I would say maybe you like call them versions. So do like, I don't know what you want to call it, like more packages version 2, more packages version 3, or something like that. Yeah, and then if you ever wanted to like fully rebuild everything, you'd go back to your original definition file and you'd paste in those other versions of packages, do a full rebuild, and then you'd have, I mean, it'd still work, but like if you wanted to, just for whatever reasons. I have like aesthetic reasons why I would do that, but you don't have to do it. As long as it works, right? All right, so let me just check on my terminal. But that one takes a little bit more time, so I have a few more things I can talk about. Usually it takes like 8 to 10 minutes. So these libraries that you see here are important for things like XML parsing, compression, text processing, linear programming. These are things that the operating system that the R package was built with, it was important for some aspect of the R package, usually compilation and things like that. There might also be missing some header files or SO files. So this, I find, is a very nice set of operating system packages that we've found are missing by default from some of these R containers. But by installing these at runtime, or sorry, at build time, not at runtime, the R packages can compile successfully, and the dependencies are explicitly documented in your definition file. So the key thing here is if the R package that you're trying to install with your, like into your personal library, but to use this container, if it needs something that's outside of the container, then your move is to rebuild the container that has everything, all the dependencies that it needs. And I will say that it can be quite painful sometimes to walk through the errors that you're getting, because there can kind of be a dependency chain reaction that you find, oh, I fixed that dependency, but now I found this one, and it's just as it's like marching through the errors. But it is just kind of the lay of the land. Same thing would happen on your laptop. If you update R, you have to update all of your packages, and inevitably you're missing something. But you're the root administrator on your laptop, so you can just, look on the internet and find out what it is, and you don't have to worry about any consequences most of the time. You should be careful, but most of the time. If you're downloading packages from reputable sources, using apt, for example, then you shouldn't get into any sticky situations. One thing I do want to point out on this repository page, if you scroll down to the bottom, I put a special box here. Some packages will not behave very well just using the R script and install packages. They will require you to install them from the source. And so to install that type of package, you would use the wget command. This would go into the post section. So this is something that you would take as a template and paste it into your definition file in the post section. It would use the wget command to download that tar file from CRAN, and then you could use R command install, which is the command line version of install packages, and then it would install that from source from the tar package, the tar file. And then bioconductor. Bioconductor packages are probably the most frequently updated packages out there, because the bioinformatics community especially is very active in using R and developing their own tools. And so these are just some steps and some templates that you can use for what you need to do if you want to install a BioC or bioconductor package. You want to install first the biomanager package and then use biomanager to install that. Is that all making sense? If that is your case, you want to check this out. Oh man, should have really done this before. Sorry guys. If we didn't need this container, I wouldn't wait. I would just cancel it and then move on. But the next step does use this. Well, does it have to? No, the next step doesn't have to use this container. The third step, the task, does have to use this container. So let's just go ahead and move forward so that we're not all waiting. All right, I'm moving into the page called 04 RScript function. So now we're going to talk about running your script non-interactively. And what I think that we should do, this one is still going to be going, so we should start a new shell. This is always available to you. You can be multitasking. Okay, so we've got our shell running here in the background. I'll actually move this over here so we can kind of watch it. But let's log in. Okay, and now let's change directory into gscratch, scrubbed, user, R, RStudio. Actually, let's just do it to that and then go into R and RStudio. So you should be back where we have been this whole time in our tutorial file. The RScript command, which we've already seen a little bit, it allows you to execute single R expressions like we saw before. It'll allow you to just send one command, but you're outside of R, right? You're not in R, but you can send commands to R with it. Uh-oh, my container like worked now, so that's good. Anyway, I'll just keep going. That'll be easier. We don't have to. The other thing that it can do, it can allow you to execute entire R scripts non-interactively. So the tool here is that you can use the RScript command with Slurm to ship your RScript to Slurm to be executed unsupervised. This is what allows you to not just have your laptop dedicated to running R packages or R analysis in the background. So I have set up a just little script called test.r, capital R, which we can look at. It is really just very small. It just does 5 + 5, and it loads the tidyverse container. Tidyverse is the library that we installed into that container. Mine now is complete, so hopefully yours is too. So the output that we will see is just going to be 10, 1, 0, and then it's just going to show the output of what happens when you load the tidyverse container. So we're going to send this RScript as a job. So the next file that we want to print to the screen is RScript submit. So if you've submitted a Slurm job before, you are familiar with this basic layout, which is to have Slurm directives at the top using the hash symbol with sbatch. This is not a command for the command line, it's a command for Slurm specifically, and it sets up the resources that you want for your job. So I'm going to name my job RScript submit. You can change it to whatever you want. For today, we're going to be using the account UWIT and the partition compute. We're going to only request a runtime of 5 minutes. On one node, one task, which means like one core. And then it's so fast that I'm only requesting 4 GB of RAM this time. And then this signal part, it just allows, if you have a longer running job, before it hits the wall time, if you are ever worried that your job isn't going to complete before it hits the wall time, this will allow your job to kind of close itself gracefully a little bit before the wall time, which could be helpful in some situations. And then sbatch with the output. This is a little bit of shorthand here. So this %x is actually going to be replaced with RScript submit. Underscore this %j is going to be replaced with the job ID. So all of the output, all the messages from R are going to be saved into a file called RScript submit underscore and then the job ID, which we don't know what it is right now, .out. So you always want to save your outputs doing R R things, because that is where any errors will be tracked, and you'll be able to go back and kind of investigate that as you would. This time we're going to use a slightly different apptainer command. We're going to use apptainer execute. We are going to bind gscratch because our R script, this test.r, exists outside of the container. But we're going to use our new container, which has all of our operating system libraries, which are not really going to be used in this example, but it's a good template for later. We're going to use the R script command, and we're going to then pass in the script that we want to be executed. Any questions about that part? So basically nothing you have to do here is, you don't have to do anything here. It's all fixed for you for this time, but you should use it as a template for later when you want to do this yourself. On the repository page, there is an optional side quest, which is to set up the email notifications for yourself if you want that. I will say I find it quite annoying, so I don't do it. But if you have a really long running job and you are keen to know what is going on with it, then you can at least set it up just for type end or type fail rather than type begin, because I think you will know when it begins. Okay, so we are going to submit this script. So we're going to do sbatch, our script submit.slurm, and that submits our job. Let's go ahead and watch it go through. So I'm going to use the watch command with the sq command -u Finch kn to watch my job. The watch command the job is already done, so it's already in state cancel job. So the one job that I'm running interactively is still going, but my other job is so fast, it's only doing math for 5 + 5, but it will eventually disappear. But the watch command submits the sq command every 2 seconds by default. So if you ever wanted to watch your job as it's going in after you've submitted it, just to make sure it gets past, a certain amount of time that maybe tells you that it is happening successfully, that's a good tool for you. So let's go ahead and see what it gave us. So like I said, it took the job name and the job ID and made our output file. So if we cat this to the screen, we have output from what we asked, 10, and the messages about the tidyverse container. So that is something that you'll use when you're moving away from your exploratory analysis and getting your R script ready to go into production. So your R script, when you submit it this way, it should take all of the inputs that it needs, should run all the analysis that it needs, and it should save all of the files that you need for your results somewhere else. So you should use R commands like ggsave to save a plot, for example. So the next part of this, we are going to, we're running a little bit out of time, but we will go back to Open OnDemand. Oops. In my other. So I still have Open OnDemand available to me. Go back into the RStudio form. Leave it as you had it before, but this time we're going to do a custom container. And it's already remembered what I did when I was testing this last night. But you're going to give it the path to the container that we just built. So we're going to use gscratch scrubbed with your username to our file where we know that that container is, and give it the container name. So when you're adding your custom R container, you're using the custom on the drop-down container field and giving the full path. You can leave your R libraries the same way that you had it before. It's remembered your preferences, and keep it the same way here. Hopefully we won't run out of jobs so that we can all see this one. I'm going to go ahead and start another one for myself just so I can. Oh, it's already running, so no problem. So once you get into R, hopefully it won't be super lagging. Okay. So I have, again, my Scratch. So I did some of these things before, but if you go from the tutorial screenshots. It looks kind of like this. You click on Scratch, you click into your tutorial files, and you find your checkpoint analysis script. And the only thing you want to change is make sure that you change this area to be the working directory that you want, so that R can also find all of the files that we're loading in here, just the example data. So I'm going to edit this and then save. And I can just run all of this code. And we will see that more PDFs are going to be saved into our directory, because I've coded that in that I want all of my plots to be output with the custom size specifications that I want. So it has just shown me the by state. Also, it does come up on plots too, when there is one loaded. There's quite a lot of data going in. Okay, so just a little fun data. If you did click on the PDF here, it would open up a tab so you could look at that quickly. Another thing in Open OnDemand, if you go back to your interactive sessions and you go to click on this Files menu and click on Scrubbed where your files are, you can also explore the file system this way, and you can find that PDF. Click on it and it will open in the window, and you can go back. You can also open the slide deck if you want to this way, because you've cloned the repository, so you have it also on Hyak. Okay, last thing, I know we're pushing time here. You can run, so in the directory, in the repository, go ahead and use that for homework. It gives you instructions on how to customize this R script submit to change instead and use the checkpoint analysis.r script, and to change a little bit about the Slurm job, but I have also the solution. So it's basically the same script, except I asked you all to change this to be 10 minutes, and then to do the mail. So this will fail. I guess I could customize it really quick. And then you don't have to change anything about this, but the instructions were to use the same container, but pass in the new version of our script and submit that with sbatch. Just as another example of how you're executing unsupervised in R analysis. And as they start, so these are from the previous time, but as that job continues to run, your files will continue to be available, but mine might be waiting in the queue. Oh, it's running now. So it was this job is the one that is running the checkpoint analysis. Okay, so what we've done today, we have talked extensively about containers and container customization. Thank you for bearing with me on that. I know that it is maybe not fun, but it is a good skill, and it helps you to learn how to install software in custom environment or in command line environments. Helps you build an environment that is reproducible for your research. We have used Open OnDemand to use a provided container for RStudio, and we have loaded our own custom container into OnDemand, and I've showed you how you can run your R scripts, install packages. You can look at the file outputs as well through your browser in multiple ways. And you now know how to edit a Slurm script and submit it for execution. You can find the output of all of everything that ran in R by tracking the Slurm output, and you can output your plots. If you, it will also save all of your plots by default because of that SIG, but it saves them. So if you refresh, It actually saves them all into one file, and I don't like the sizes, so, but that can be useful too. The reason that it output the R plots that way was this signal. That's why it did that. It doesn't do that by default, but this script does. Okay, so that's it. That was all the tasks. You have until Monday to continue to use the UWIT account, and free access, go nuts. If you're a student, you should look into getting access from the Research Computing Club. Don't forget about our training documentation and our learning resources where this video will be posted. And you have other videos here to check out on your own time. You can also find upcoming events here. And I will put the link, the QR code for a feedback survey. If you could please leave us some feedback and tell us how this went. If it was too fast, if it was too boring, I'm open. Thank you.
What is the difference between .slurm and .job?
Nothing. So you can actually have it be any file ending. I think the most accurate would be .sh because it is a bash script, and most bash scripts end with sh. That's just kind of a file convention. I always name mine .slurm for the trainings because I just want that to be very clear when you're looking at the files in all of the workshop materials. I used to call them .job, so that's probably why you've seen that and you're familiar with that. So the file ending does not bear any weight. If you submit the SBatch scripts or the slurm scripts, they have at the top this bin sh or bin bash that tells the Linux system and Slurm that this is a bash script, so the file ending does not matter. Okay, and so if you want to terminate your task from the command line, you would use scancel. So let's see. So if I wanted to use scancel to cancel one of these jobs, I could cancel one of these on Open OnDemand because I'll do this one because I'm not using it, haven't started it up. Scancel. Like that. And then I see that it's gone into the canceling state. All right. Cool. I'll be here at 2 p.m. for office hours if you want to continue.